Okay, so I'm going over module 11.3, explain 2, and I'm on page 560. So we're going to go over solving cube roots and 1/3 power equations. So remember that 1/3 power and cube roots are the same thing. They're just written in different formats. So it says you can solve radical equations that involve roots other than square roots by raising both sides to the index of the radical. So to solve the cube root equation, or equivalently an equation involving a power of 1/3, you can cube both sides of the equation and solve the resulting equation. So the index, where it says here the index of the radical, that index of the radical is the number that's here. So if that was a 4, I would raise both sides to the 4th power. If that was a 5, I would raise both sides to the 5th power. And so since we're talking about the cube root, or an index of 3, we're going to raise both sides to the 3rd power to solve. And so our steps for this are going to be 1, isolate the radical. And so right here I have a radical and then I have a +7. So I'm going to subtract 7 to both sides and I get -2. And then it says to, once you isolate the radical, you're going to cube both sides. So if I cube both sides here, like we have in this step here, notice that the cube root and the cube are inverses of each other. So they cancel each other out and I just get x plus 2 equals, and then -2 cubed is just -2 times -2 times -2. So +4 times a -2, and that's how they got the -8. And then after I simplify, which is what I did right here, I'm going to then solve for x. So to solve for x, I subtract 2 to both sides, and I get that x equals -10. And so our solution here is x equals -10. And in fact, if I plugged it back in to my original equation, I would get the cube root of -10 plus 2 plus 7 equals 5. Notice the 7 is not in the radical. So -10 plus 2 is -8. And the cube root of -8 is -2. So I have -2 plus 7 equals 5, which is a true statement. So that is my solution, and I checked it. Now, if I turn to the next page, we're on 560, so we're going to 561. Let's try part B to this. Okay, so remember, step 1 is to isolate your radical. And right here I have the cube root of x minus 5 equals, so it is on one side of the equal sign by itself. It's already isolated. So I can go ahead and move on to cubing both sides. And when we cube both sides, notice that the cube root and the cube are going to cancel, and you're going to get x minus 5. And then here you have x plus 1 cube. And so I'm going to move this over and show this work here. So I have x plus 1 times x plus 1. Actually, let me do it in a different color so I can show it a little bit clearer. X plus 1 times x plus 1. So it's x plus 1 cubed, and I'm going to distribute the first two. So I'm going to distribute the red x plus 1 to the blue x plus 1. So I get x times x is x squared. X times 1 is 1x. 1 times x is 1x. And 1 times 1 is 1. So if I combine these, I get x squared plus 2x plus 1. And now remember that this was only the first two, and so I still have to distribute this to the other x plus 1. And so, let's see, x squared times x is x cubed. X squared times 1 is x squared. 2x times x is 2x squared. 2x times 1 is 2x. And 1 times x is x, and 1 times 1 is 1. So now if I combine like terms here, I get x cubed, that's the only x cubed. X squared plus 2x squared is 3x squared. 2x and x give me a 3x. And then I have a plus 1. So I'm going to go ahead and fill that in over here. X cubed plus 3x squared plus 3x plus 1. And now I'm going to come back over here and simplify. So to simplify, I need to move everything to one side. So I'm going to subtract x, and I'm going to add 5. And so I get 0 on this side, and I get x cubed plus 3x squared plus 2x plus 6. And then it says to begin factor by grouping. And so let's just recall that when you have 4 terms, 1, 2, 3, 4 terms, you can group the first 2 and group the last 2 and then take out what they have in common. So these first 2 have an x squared in common, and so I'm left with an x plus 3 when I take that out. And then these last 2 have a 2x and a 6, so they have a 2 in common, and I get an x plus 3. And since they both, the x plus 3 and the x plus 3 match, I can factor that out, and what I'm left with is x squared plus 2, which is where this comes from. And then after you factor, like we did on the other one, we want to go ahead and set these equal to 0 in order to solve. So I have x squared plus 2, and I have x squared plus 3. So solving this, I subtract 2 to both sides. And it says, because there are no real values for x, for which x squared will equal -2, the only solution is this other one over here, which is subtract 3 to both sides, and I get x equals -3. So remember that there's no number you can square that will give you a negative number. So this one right here does not work, and so our only solution is this one that does work. Okay, and just a quick recap of how we did this. I'm going to go back a page to here. So in order to solve cube roots, remember that you want to still isolate the radical like we do with square roots, cube both sides, or if this was the 4th root, remember, raise both sides to the 4th power. If it was the 5th root, raise both sides to the 5th power. You want to simplify, and then you want to solve for x. And sometimes when solving for x, like it did on this example here, sometimes it's going to require you to factor in order to solve. And then, in the case for this one, there were no real values for this expression, so that's not our solution. Our only solution is this one here.